Trigonometric ratios, question 16. Draw the given triangle, solve each triangle and find the sides correct to one decimal place and angles to the nearest degree. So in this series we have got three questions very similar. I will do them for you, but I'll encourage you to do them in an alternate way. Right? I'll tell you what I really mean. Here we have a triangle ABC with angle B equals to 90 degrees, AB as 6 and angle A given to us as 30 degrees. So let's try to sketch this first. So this is our right angle triangle, right? And let's say this is angle A, and let me draw a line here which makes almost 30 degrees. So this is B, which is 90 degrees for us. This is A, and this angle is given to us as 30 degrees. And that's the point C. AB is 6 units, right? Let's write 6, right? And now let's try to solve this problem. Now since we are given angle and the adjacent side, this side is the adjacent side between the given angle and 90 degrees, which trigonometric ratio should we use? It should be cosine, right? So we have cos of 30 degrees is equals to adjacent side over hypotenuse, right? So adjacent side is 6 and hypotenuse is AC. Now from here we can find what AC is. So AC is equals to 6 divided by cos of 30 degrees, which is equal to 6 divided by cos of 30 degrees, which is 6.9282. So we need to sides to one decimal place. So one decimal place will give us 7.0, right? So one decimal place will be 6.9. So we'll write this as equals to approximately 6.9. That is one decimal place, yes. So we got our side AC. Now to find, let me write 6.9 here approximately, right? Now to find CB, which is the opposite side, we can use tangent ratio, right? So we have tan of 30 degrees is equals to CB over six, which is given to us, right? So tan is opposite over adjacent side, right? So CB over 6. Now CB is equals to, we can cross multiply 6 times tan of 30 degrees. So which is 6 times tan 30 equals to 3.464. And we'll round it to one decimal place, which will give me 3.5. So CB is 3.5 for us. So we got CB. We can always find angle C using 180 degrees as the sum of the angles, right? So we can say angle C is equals to 90 minus 30 degrees. This is 90 itself, therefore it is 60 degrees, right? So angle C is 60 degrees. You could have found angle C by using trigonometric ratios also, right? Now for that, I will appreciate that you should always use 4 decimal places. Let's do with AC as 6.9282 and BA given to us as 6. So if we want to use 6 and 6.9, then which trigonometric ratio should we use? So let's figure it out. So what we are trying to do is to find angle C using trigonometric ratio, right? So we will use these two sides, this side and this side, which is the opposite and hypotenuse for angle C. So when it is opposite over hypotenuse, it is sine. So we have sine C is equals to BA, which is opposite side, over CA. Correct? Now, so angle C will be equals to sine inverse of BA, which is 6, divided by CA. So I'll not use 6.9, I'll use 6.9282. And then figure out the value. So we've got sine inverse of 6 divided by 6.9282 equals to 60.00. So we get 60.00. And round it to one decimal place, we get 60 degrees, correct? So that is how we are going to do it, right? It is kind of important to use 3 or 4 decimal places to get accurate results in trigonometry, okay? Thank you and all the best.